Okay, so move to question number 2. So in this question, a random variable x has a probability density function given by f of x is equal to 1 by 4 in between minus 1 by 2 to plus 1 by 2. 2x minus 3 by 4 in between 1 by 2 to k. 0 otherwise. So underline the keywords. What are the keywords? It is a probability density function. So you should keep in your mind the properties of probability density function. Yes, probability density function. So what is the speciality of a probability density function for any random variable? The total sum of probability is equal to what? That is equal to 1. Since it is a variable distribution, it is a continuous variable distribution, integral of, it starts from minus 1, correct? Or anyway, usually where integral starts from, any function starts from minus infinity to plus infinity of probability density function is always equal to 1. So that is a property we already know. Now, where k is a constant, okay? So what is our first aim? Our aim is to sketch the graph of this. Our aim is to find the, or our aim is to sketch this graph. So it's a very simple question, because from minus 1 by 2 to 1 by 2, this is a constant. That means it is a straight line that is passing parallel to x-axis. And after that, what happens? It is a equation, general equation is straight line. This is a general equation of a straight line in the form of y is equal to mx plus c. And you can see the coefficient of x that is positive. That means it is having a positive gradient. So how will you do this question? How will you do this question? Anyway, we will first of all draw our x and y axis. So this is our x and y axis, and this is 0. And it's anyway, it starts from minus 1 by 2, correct? So this is minus 1 by 2. This is plus 1 by 2. And 1 by 2 to k. So we don't know where this k is, and where we don't know what is actually the value of k. So we will mark these 3 points, minus 1 by 2 to 1 by 2, and then 1 by 2 to k. Now, you can see the first part is having a constant value 1 by 4. This value is, I'm keeping it as 1 by 4. So from minus 1 by 2 to plus 1 by 2, the same value stands, correct? Same value stands. So that is a straight line that is passing parallel to x-axis. Then after that, what happens? As I already mentioned, it is having a positive gradient. So that means it should give the graph is going upwards. And once it reaches k, what will be the value of f of x? So what is f of k? F of k is 2k minus 3 by 4. 2k minus 3 by 4. So 2k minus 3 by 4 is a value which is above 1 by 4. So this value I am keeping it as 2k minus 3 by 4. So then once it reaches k, it takes this value 2k minus 3 by 4. Since it is having a positive gradient, I can draw like this. So this is the graph. This is the graph of, or the sketch of y is equal to f of x. That means f of x is the probability density function. Yes. So we have done this. It's 2 marks question. Then by forming and solving an equation in K, show that K is equal to 1.5. How will you do this? Idea is very simple. Why? Area under this graph, or integral of -1/2 to 1/2 f of x dx plus 1/2 to k f of x dx is giving the total area 1, because area under the probability density function will be always, area under the probability density function is always what? It is always -1. So this value is, the area under this is always -1. It's not -1, I mean it's +1. Sorry, it's +1. The area under this graph is always +1. So integrate it. So -1/2 to 1/2. What is the f of x at that place? It's 1/4, correct? So -1/2 to +1/2, 1/4 into dx, plus then 1/2 to k. At that moment, it is 2x minus 3/4, correct? 2x minus 3/4 dx is equal to 1. So if I'm integrating this part, what happens? If I'm integrating this, 1/4 into x plus this is 2x square by 2. So this upper limit and lower limit are -1/2 and +1/2. And this is 2x square by 2 minus 3/4x. The limits are 1/2 and k. The total area is 1. Then upper limit minus lower limit. So 1/4 into 1/2 minus 1/4 into 1/2. So that is the first part. Plus anyway 2 got cancelled, right? So it becomes k square minus 3/4k minus 1/2 whole square minus 3/4 into 1/2. And total area is 1. So 1/4 into 1/2 is 1/8. Minus into minus becomes plus. Again, it's 1/8. Plus k square minus 3/4k. This becomes minus 1/4. Minus into minus becomes plus 3/8 is equal to 1. So now you can simplify this further. How you can simplify this further? 1/8 into 1/8, that is 2/8 plus k square minus 3/4k minus 1/4. So I can make a common denominator. So it becomes -2 plus 3. That's anyway, it's plus 1/8 is equal to 1. Two by 8 plus 1/8, it is 3/8. So k square minus 3/4k plus 3/8 is equal to 1. K square minus 3/4k plus 3/8 minus 1 is equal to 0. So k square minus 3/4k minus 5/8 is equal to 0. I took it. I took what? I took this the LCM of 3/8 and minus 1/8. Then I added it. Now you can make it into a beautiful quadratic equation, because we can, usually for quadratic equation, try to avoid the denominator part. So you completely multiply this with the 8. So what happens? It becomes 8k square minus 6k minus 5 is equal to 0. So if you are factorizing this, we can say that it is 4k minus 5. But I'm not going to the factorizing part that you already know. 4k minus 5 into 2k plus 1 is equal to 0. So what are the two values of k we will be getting? We will be getting two values. Either k is equal to 5 by 4, that is 1.25, or k is equal to minus half. Minus half means it is minus 0.5. So two values of k. But we know that it is given in our question, since k is a value greater than 0, this we can neglect negative 0.5. Hence, k value is 1.25. So therefore, k value we will be accepting it as 1.25. Clear? So that is the idea about this part. So this was the sketch, and this is the solution for B part. Now, see, use calculus to find E of x. E of x means what? E of x is the average or the mean. So what is the formula? Minus infinity to infinity x into f of x. That is the formula for finding the mean. So minus 1 by 2 to plus 1 by 2 x into 1 by 4, because 1 by 4 is the function, into x dx, plus 1 by 2 to, anyway we got this k value is 1.25, correct? So 1.25, then x into, this is 2x minus 3 by 4 dx. So if I'm integrating this, 1 by 4 into x square by 2, then we should apply the limits, minus 1 by 2 and plus 1 by 2, plus if I'm expanding this, it becomes 2x square, right? So 2x square becomes ultimately 2x cube by 3 minus 3 by 4 x square by 2. That we should integrate it from 1 by 2 to 1.2. So then you apply upper limit and lower limit. So anyway, 1 by 4 into 1 by 2, we can take 1 by 8 common. 1 by 8 into 1 by 2 whole square minus 1 by 2 whole square, plus 2 by 3 we can take outside. 2 by 3 into 1.25 whole cube minus 1 by 2 means it is 0.5, right? So 0.5 whole cube plus, not plus, because it's minus, right? So minus 3 by 4 into 4 into 2 is 8. So we can take 3 by 8 outside, and this is 1.25 square minus 0.5 square. So substitute these values. So please substitute these values. So if you are substituting all these values, what we will get? We will get it as 93 upon 128. Hope you got it, the idea behind this. So that is the answer for C part. Then calculate the interquartile range of this variable x. So what is basically interquartile range? That is upper quartile minus lower quartile. Upper quartile minus lower quartile. So how will you find this upper quartile and lower quartile? For that, we first calculate the cumulative distribution function, or CDF. We will be calculating. So we will be calculating the CDF, cumulative distribution function. Recall what is the probability density function here? It is 1/4 when it is between -1/2 to +1/2. Then this is 2x minus 3/4 in between 1/2 to 1/2 to k. K is already we calculated, that is 1.25, correct? And 0, not 0, 0 otherwise. Now we will be calculating what? CDF. So CDF is capital F of x. Capital F of x. So how will you calculate capital F of x? What is the relation between capital F of x and small f of x? Capital F of x is integral, whatever be the function it starts from. So from a, suppose for example, if it's starting from a, then the upper limit we will be always keeping it as x of f of x dx. So capital F of x, we will be saying it as -1/2 to x 1/4 dx. So that we will get it as 1/4x plus 1/2. 1/4x multiplied by, it's not 1/2, it's 1/8. 1/4, because upper limit minus lower limit means it is 1/4 into minus 1/2. So 1/4x plus 1/8 is the cumulative distribution function for -1/2 to +1/2. Then capital F of x is equal to, we know that once it reaches to the value of x, it becomes, when x is taking the value 1/2, 1/4 into 1/2, that is 1/8. So 1/8 plus 1/8, it's 1/4. So 1/4 plus integral of 1/2 to 1.25, 2x minus 3/4 dx. So here we will not keep the upper limit as 1.25 because it's go up to 1.25, but we need an expression, so we'll keep it as x. So 1/4 plus x square minus 3/4 x, that is upper limit, minus 0.5 square, because x square 0.5 square minus 3/8. So it eventually becomes 1/4 plus x square minus 3/4x minus, this is minus 1/4 plus 3/8. So 1/4 minus 1/4 got cancelled. It becomes x square minus 3/4x plus 3/8. So this is the cumulative distribution function. So I will write this CDF here. That is capital F of x is equal to, capital F of x is equal to 0 when whatever be the value of x less than minus 1 by 2, less than or equal to minus 1 by 2. Then next is 1 by 4x plus 1 by 4. Yes, not 1 by 4, x plus 1 by 8 when it is between minus 1 by 2 to plus 1 by 2. Then it is x square minus 3 by 4x plus 3 by 8 in between 1 by 2 to 1.25. And next it is 1 when x is greater than 1.25. This is the cumulative distribution function. Now, this is not our actual aim. This is actually a stepping stone to our answer. How? We need interquartile range. So what is interquartile range? So interquartile range means we need to find the Q1 and Q2. What is the meaning of Q1? That our quartile, that means the point below which 25% of the value or 25% of the probability lies. See, come to the figure. So here we need to find what? The point at which the entire probability is 25% below. 25% below. So if you want to find that, we need to find, maybe somewhere here is our point Q1, such that we don't know exactly, I'm just making randomly, such that this is 0.25. And then randomly somewhere here is our Q3, such that the area below Q3 is 0.75. So our aim is to find what? Our aim is to find the area, or we need to find the point at which the area is giving the cumulative probability is giving 0.25. So f of Q1. So in which equation we will substitute? Anyway, 0.25 means most probably it lies in this part. So f of Q1 should be what? 0.25. Probability should be 0.25. So 1 by 4 into 1 by 4 into Q1 plus 1 by 8 must be 0.25. So Q1 by 4 is equal to 0.25 minus 1 by 8. That implies as Q1 is 0.25 minus 1 by 8 into 4. So 0.25 minus 1 divided by 8 multiplied by 4. Yes, we got that value. What is the value? Q1. Q1 we obtained it as 0.5. Now f of Q3, that is 0.75. So most probably it falls in this region. Why it falls in this region? Why it falls in this region? Because 0.5 itself is the border between this straight line and the parallel line, right? So f of Q3 is 0.75 means you substitute in this equation. So Q3 square minus 3 by 4 Q3 plus 3 by 8 must be 0.75. So anyway, it's a beautiful quadratic equation. So Q3 square minus 3 by 4 Q3 plus 3 by 8 minus 0.75 is equal to 0. So you completely multiply this with the 8. So what happens is 8 Q3 square minus 6 Q3 plus 8 multiplied by 3 divided by 8 minus 8 multiplied by 0.75. So we will get it as minus 3. So solve the quadratic equation. Solve the quadratic equation and find the value of Q3. So you can use either factorization or quadratic formula method to find the answer. So we will get two values of Q3. One value is 1.093 and another value is minus 0.343. Anyway, this will not take the value. Why? Because Q1 itself, it is 0.5. So that means Q3 must be a value which is greater than 0.5, right? So only one possibility is Q3 is equal to 1.093. 1.093. So I will write here interquartile range is Q3 minus Q1, and that is equal to 1.093 minus 0.5, and that is equal to 0.593. So that is the idea about this question. So we did all the parts of second question, right? Okay.